that's what the old one.
Okay, so, like I said, when you leave today, you'll know what all that means. It's really, really simple. Okay, most of it's all on this one. A relation is a pairing of input values with output values. It can be shown as a set of ordered pairs, x, y, where x is the input and y is an output. So basically a relation is a set of ordered pairs, that's all it is. So that graph we just looked at, this is a relation. It's a set of ordered pairs, right? It's just in a graph form. A graph is a picture of solution to a problem. This is section 1.6, yes. The set of input values for a relation is called the domain, and the set of output values is called the range. So the domain is the x values, and the range is the y values. So going back to that warm-up, our domain is those four numbers, and our range is those four numbers. Okay? Just remember, domain is x values. If I ask for the domain, you just give me the x value. If I ask for the range, you just give me the y value. Okay? Again, a relation is a set of ordered pairs. Not talking about your cousins and aunts and uncles. So, this is called a mapping diagram. The domain of this mapping diagram is 2. It's only got one number. And the range is A, B, and C. So the relation is this set of ordered pairs. So you might have to do a mapping diagram for homework tonight, but when we get to the quiz or the test, actually, when we get to the test next week, I don't have you don't have to do a mapping diagram. Just understand that the mapping diagram is putting the 2 with A and the B and the C. All right, so Drake,
Yes.
what is the domain of this relation? What's domain again? X value. So give me the other X value.
120. 140. 160. 180.
Very good, sir. Hunter.
Yeah.
What's the range?
5, 6, 6.
Very good. You don't have to write it twice if it shows up more than once. That's all you got to do. Simple, right? All right. I want to say Allison, but it's Alyssa, right? Alyssa.
-2, -1, 0, 1, 2, 3.
Very good. Any questions? Everybody understand why that's the domain? Nathan, what's the range?
Zero. It's the same thing as all.
Yeah, you gotta look at, there's gonna be 6 of them. Yeah. Yeah.
1, 2, 3.
Should be negative. Okay. This this y value is -3. That one's -2. That one's -1. That's 0. That's 1. That's 2. Right? Y values. That's this way, right? Vertical. X values. Domain. That's this way. Horizontal. Okay? So, I expect you to be able to look at a graph and give me the domain and range. Or look at a set of ordered pairs and give me the domain and range. Okay? Suppose you're told, this is an old time cell phone. Suppose you're told that a person entered a word into a text message using the numbers 6, 2, 8, and 4 on a cell phone. It would be difficult to determine the word without seeing it because each number can be used to enter 3 different letters. Okay, back when the cell phones first came out, you didn't have a keyboard. You had just your keypad for like the phone, just with the dial numbers. But if I wanted to text the letter N in a word, I'd have to hit the 6 twice for the N to pop up. And then let's say A was the next letter. Then I have to hit 2 once. And then let's say it was B. Then I have to hit 8 3 times. That's how you would have to text when cell phones first came out, because we didn't have the keyboard. All right? So this 6 could be either M, N, or O, and the 2 could be A, B, or C, and the T could be, or the 8 could be T, U, or V, and the 4 could be G, H, or I. So since this is an Algebra 2 class, what word do you think they're texting? Math, yeah. Okay? So if you were told to enter the word math into a text message, you can easily determine that you would hit those 6, 2, 8, and 4 numbers. Okay? So we have a set of ordered pairs here. We have a relation here, right? It says a relation in which the first coordinate, the x value, is never repeated is called a function. So in this relation, none of the x values were repeated, so that's a function, a type of relation. Right? In a function, there is only one output, one y, for each input x. So the way I say it, for every x, there's one and only one y. Okay? So we've got relations. We've got a set of ordered pairs. A function is a type of relation. Yeah. Every x has one and only one y. Okay? Although a single input in a function cannot be mapped to more than one output, okay? Every x can't have more than one y. 2 or more different x's can be mapped to the same y. That's okay. So repetition in the y is okay. If your y value is the same for all your x's, but the x's didn't repeat, okay, it's still a function. So this x has how many different y's? 3, so that's not a function. These 3 x's have the same y, but each x has only one y, right? So that is a function. Okay? So this set of ordered pairs, A2, B2, C2, would be an example of a relation that is a function. 2A, 2B, 2C is a relation, but it's not a function. Okay? All right, so let's think of some real life situations. Is this situation a function? It says, let's say I went to Mark's and I'm going to the milk. I want to get my 2% milk, my blue cap. All right? And I go and I get 2 of them. Will every one of those have the same price? Or will this one and this one have different prices? blue caps? They're all gonna be the same, right? Aren't they? Or maybe tomorrow they might change, it might got cheaper or more expensive. But today, when I go in there, all the 2% milk should have the same price, right? Unless it's marked. So that's an example of a function, right? How about the types of fruits and their colors? All fruits have the same color. No, give me an example, Cole.
What?
A fruit, a type of fruit that has different colors.
Strawberry.
Yeah?
Oranges,
So strawberries are what two colors?
Red.
Or three colors?
Green.
Oh, there are green strawberries?
More like the stem.
Usually a strawberry is just red, right?
Okay.
So let's pick a different fruit. What keeps the
Apple.
doctor away? Yeah, apples, right? Apples are red, yellow, and green, right? And hopefully not brown when you eat it, right? But, so, will if we think about apples, would that be an example of a function? No, because every apple doesn't have the same color. If we're talking about colors, fruits and colors, right? So you getting the idea what we're talking about as far as when a relation is a function and when it's not? That's all we're trying to figure out here. All right? Is this an example of a function? Some people with bigger feet, do they got to pay more for the same shoe? No.
Sometimes.
Not usually. Not if it's the same type of shoe, you know. You're gonna get LeBron James or something. Okay? So that's an example of a function. All right? Shoe prices and the size. It's the same, you know, if they're different shoes, obviously they're gonna be different costs, right? But they're not different shoes. That X, the type of shoe, and then the size of it, not gonna change the price, right? All right, how about this? Let's say Garrett and Robert go to Mark's, they get 10 items in their cart, they're gonna pay the same amount because they both got the same amount of items? No. So is that a function? No. That would not be a function, all right? Maybe all of us, maybe every one of us could go get 10 items and none of us would have the same amount, right? Unless we all got the exact same things, right? So again, a function, every x has one or many y's. One and only one, right? All right, every point on a vertical line, which way is that? Is that this way or this way, right? Verticals up and down. Okay, so every point on the vertical line has the same x coordinate. Right? If I look at the y-axis, what's the x value on the y-axis? 0. Every point on the the y-axis, the x value is 0, right? So a vertical line cannot represent a function because the x has different lines, right? So if a vertical line passes through more than one point on the graph of a relation, the relation must have more than one point with the same x coordinate. Therefore, the relation is not a function. So they're going to give you pictures of graphs. And they're going to ask if it's a function or not. And in your mind, you're going to draw what? What are these called? A vertical line, right? And if the vertical line hits the graph 2 or more times, you're going to say what? Is it a function or is it not a function? Not a function. If it only hits once, it it would be a function. Okay, that's called the vertical line test. Okay, that's what this is saying. So, looking at this graph, this red line, if I draw a vertical line anywhere, how many times do I hit the red line? Once, so that's a function. But if I look at this one, and I draw a couple vertical lines, what happens? It hits more than once, right? It's twice, so it's not a function. So that's the vertical line test. That's a quick way to look at a graph and tell if it's a function or not. Both of these are a set of ordered pairs. Both of those are relations, right? But one of them's a function, one isn't. Audrey, is this graph a function? She says yes. You guys agree with her?
Yes.
Are you sure? You're gonna agree with her?
I do.
Audrey, really? All right, good. You should. Good job. All right. Mary, is this graph a function? No. All right. Give me 2 points that a vertical line would pass through. It says if not, you said no. Identify 2 points a vertical line would pass through. So give me 2 coordinates.
0, 2.
0, 2. It doesn't quite go through that. You mean like right there, about 1.5? 1.75? I'll go with that. Then what's the other one?
2, 3.
Vertical line. You're looking at this one, right? So there's the one you told me. Not quite 2, right?
Oh,
So what's the other one?
1, 2.
1, 2 would be here.
Oh, for the other one?
Yes.
Oh, okay. 0, -2.
Good. Those are 2 points that vertical line passed through. You guys understand what I was asking?
Yep.
Okay. Derek, is that a function? Yes. Good. Joey, is that a function?
No.
Why not?
Oh, wait. Is it like stops or no? Oh, no.
Are you talking yourself into it or out of it?
Well, I don't think it is.
Okay, that was your first thought, right?
Yeah.
That was what your gut said, right? Go with your gut. So give me 2 points that a vertical line would pass through.
1, 2, and then 1, -2.
Very good. That is correct. Any questions on that? What if I change this to a circle instead of a dot? Would it be a function then? Yeah, it would then. You guys understand why? What's this circle with nothing in it? An open circle mean? You're not including that spot, right? So really there's nothing there. So if I drew a vertical line through there and then through that circle, it's not really hitting something. Does that make sense? You know, when we did number line graphs, we had some circles because we weren't including that number, right? We're going right up to it, but not including it, like 3.000001 would be included, but 3 wouldn't, right? Or 2.99999 would be included, but the 3 still wouldn't be included. You understand? Guys are good. All right. Looking at number 4 here. Great, so I'm gonna pick on you. What's the domain of this graph?
Would it be -3? And then the one that's like sorta in between?
What are you looking at when I ask you for a domain?
The x value?
Very good, the x values. So let me make it a little bit more. Give me the answer in interval notation. All of you should be thinking about what that answer is. Don't say it out loud, but think about it. What number do you think is going to work? What is one of the x values?
-3.
Okay,
And 3.
and 3. Good. Those are the two. You're correct. What goes around those when it's in interval notation? Are we going to include the -3 and 3, or are we not going to include it? We're going to include it. So what symbol did we use?
Bracket.
Yes.
Hold on.
Is that right?
Somewhat. The ends are -4 and 4. Yeah, it's actually 4 and 4.
Oh,
Right. Here's the 3, right? How about the range? Ava?
1, right?
Mm-hmm.
Yeah. I'd probably be the 3, right?
Mm-hmm. And do I use brackets or parentheses?
Bracket being included.
Yeah?
3.
You guys all understand why it's those two numbers? And why it's brackets? Because we're including those numbers. If we did parentheses, we wouldn't be including that. But it goes through there, right? The red line goes through -4 and +4, -3 and +3. And when we do an interval, we're including all the numbers in between, right? And if you look, as this thing goes up and comes back down, it's including all the x values from there to there, right? And then the y values are from there to there that it's included. All right, so here's your assignment. You're welcome.
I think I stopped with me.
Yeah, might as well. What do we got? About 6 minutes left? 7?
Oh.